Okay, we're going to look at a hyperbola problem now. And let's just read through it. It says the diagram below shows a hyperbola that's defined by this function here. G of x is 2 over x plus p in the bottom and plus q with asymptotes of y equals 1 and x equals minus 1. So x is always equal to minus 1. Y is equal to 1 is the horizontal. There's the vertical one. Well, this first one's pretty easy if you just know what the horizontal asymptote is always y equals q. So q is 1. Well, that's pretty easy. Q is 1, but you got to be careful with the horizontal one. It's always the opposite of the number here. So if it's minus 1, p's got to be plus 1 to make this 0, because the horizontal asymptote always works out to be 0 it always creates a situation where there's 0 in the bottom here, which makes it undefined. That's the place where the hyperbola can't go. So p is 1 and q is 1. Let's look at the next part. Okay, the next question says calculate the x-coordinate of t. Well, that's an x-intercept, so we've got to let y equals 0. If we let y equals 0, well, this is one way to do it. You multiply everything by x plus 1, you'd get 2 here. The x plus 1 would cancel, and you go 1 times x plus 1 is x plus 1. Well, 1 plus 2 is 3, and then just subtract x from both sides. Minus x is 3, so x has to equal minus 3. They did it a bit differently here. They multiplied everything by x. Well, they did the same thing, but they did a couple of steps. I like multiplying by x plus 1 and getting this, and then subtracting x, and then multiplying by negative 1. That's a little clearer for me. This is the government memo. Let's look at the next part. Okay, it says, write down the equation of h of x equals g of x plus 5. What's the equation of the vertical asymptote? Well, the normal asymptote is minus 1. And all you have to know is if you're adding inside a bracket in one of these functions, a hyperbola, a parabola, even if you're adding in a trigonometric function, you do something surprising when it's in the brackets here. Plus 5, you might think, oh, maybe it goes 5 to the right. But it does the opposite. It goes 5 in the negative direction. You must subtract 5 and you'll figure out where the new asymptote is. Well, here's the asymptote, minus 1. If we subtract 5, we're going to get to minus 6. Minus 1 minus 5 is minus 6. This is the equation of the asymptote of this new function. X is always equal to minus 6. Okay, let's look at the next one. Here, the last one. This one says, what do you think the length is from O to S? Well, I'm going to have to figure out what S is, no matter if I'm going to figure out what OS is, the origin to S. So how would I figure out S? Well, it looks like it's where this line, y equals x, and the hyperbola cross each other. Well, the way you find out where two functions cross each other is you let them equal each other. Well, there's the function f. There's the other function, well, I'll call it g. You just let them equal each other. Now you multiply everything by x plus 1. You just get 2 here. The x plus 1's cancel. 1 times x plus 1 is x plus 1. And x times x plus 1 is x squared plus x. Well, you subtract the x's from both sides and you get x squared equals 3. Take the square root, and now you have the x-coordinate of s. X equals root 3. But since y equals x, the y-coordinate must also be root 3. So you know it's root 3 and root 3 here. Well, you're supposed to find this here, but you just figured out that this distance here is root 3. And you know that's root 3. Well, I can find out OS. Isn't it the hypotenuse of this triangle? I think it is. So you just use the Pythagoras' theorem. You square root 3, you get 3. You square the other y root 3, this root 3 right here, you get 3. And 3 plus 3, OS is 6. Oh, rather, OS squared is 6. So the answer to what is OS, you have to square root it. So you go a squared plus b squared, you get c squared, but then you have to square root it, and that's 2,45 units on your calculator. Just put it in there, and there you go. That's the distance OS. That was a little bit tricky.